What's up, people? We'll be doing programming today, and specifically, we will be doing C today. So, we will be doing C because I know that you need to uh, also learn the programming languages. I mean, why would you just, what do you call it? Just do the maths and without any program, right? So, you do need a programming language. And yesterday, I did the fixing and whatnot. Oh, Valentina posted. Cool. Anyways, so let's combine entirety of the only reason I'm doing embedded one. Oh shit. Okay, that's a green screen. The only reason I'm doing the embedded one is because like I know that you can do this normal C programming language, but usually the normal C programming language is not is different from the embedded one. The embedded one mostly focuses on the hardware point of view and which closely resonates to mine. As of now, I'm using the software. Facts. I'm learning the software one, but you also need the hardware, right? You need some chip or you need some hardware model to actually be able to, run that model that I'm trying to do, like modeling the trajectory, modeling the what do you call it? Modeling uh, the trajectory, the wind disturbance, the sensors, and all that stuff. You can't just implement a software. That software must exist inside the hardware. Yeah, so software comes first, definitely facts. Software comes first, but you also need a hardware to actually integrate that or insert that into the your missile or rocket. In most cases, missile. I'm focusing on the missile, so it doesn't matter. Missile, rocket. The, I mean, this works for both missile and rocket. I think what we're going to do is do like one whole example. Okay, there is quite a lot. What I'll do instead is go to content and nah, not ChatGPT. DeepSeek is better. DeepSeek is way better. DeepSeek is better. Can you teach me everything step by step? Like teach everything step by step. Like slowly. Calm down. Can you and where's the abstract? I tried. I really tried. I mean, is it possible to teach me the chapters, like the sub chapters, one by one, like one step, like one section, explain that and the coding. Let me understand what's going on, and then we can move to the next one, please. And we're gonna go 2 hours. How do I run for politics? Just like you. And so the objective tells us we should be able, what should we be able to do and stuff like that. Okay, what's this? Basic structure of an embedded C program. So void main int hardware. So set up the clocks, the GPIO, the ADC. What's GPIO? What's ADC? Okay. What are stop. Okay. So let's say for example float thrust. Okay, is it possible to explain again? Possible to explain it again? I'm confused. It's going to right include stdio.h int main. So before learning anything, you need to know what you'll be able to do at the end. For embedded C in a rocket guidance context, the objectives are write the C code that runs in small flat computer like limited memory or no keyboard and screen. Control the hardware directly, like the sensors and actuators. Meet hard real-time deadlines. So every 100 millisecond, a new steering command is computed. Implement the adaptive algorithms that update the rocket parameters during the flight, and ensure that the code is safe, predictable, and crash-free. Because your adaptive guidance must run in under 100 milliseconds. So that's the um, core aspect. We want the program to run faster. And obviously, you need C because C is the best for embedded because C is a low level language. So, embedded C is standard C plus hardware plus real time. So, like I said, embedded C is mostly is for hardware programming languages. So, mostly like if you want to think of like actuators or sensors, or so in my case, you'd be using C for actuators or sensors or measuring the trajectory angle. So let's say, for example, if you want to measure the trajectory at every millisecond, then obviously you're going to use the embedded C, because the normal C programming language, I mean, they're the same thing, but embedded C is more of like it's similar to C programming language, but that focuses mostly in the hardware point of view. Normal C is like, let's say if you want to do C for, I don't know, computers, right? If you want to do C for computers, or if you want to build a software, then you use C, just C, but not embedded C. Embedded C is that you have a software, fine, but you also need a hardware because you also have codes that need to connect to the hardware. So in a normal PC, your program runs on top of an operating system like Windows or Linux. In my case, I'm using Windows, even though I also have Linux. In an embedded system, your program runs directly on the metal, right? On directly on the chip. So in my case, I'm going to directly run it on the chip. So let's say, for example, if I were to compute, let's say, for example, if I were to do the backend uses C. It doesn't use embedded C, right? Backend, like let's say, for example, if you want to build a software, if you want to build a startup, then obviously you need C. You don't need embedded C. Reason being is because embedded C has programs that you need a hardware to actually function that, right? So obviously, so this is just normal C. So main, printf, malloc, so no dynamic allocations and stuff like that. Slowdowns are okay, right? So int read accelerometer, and then you return whatever the value is. The beginning, so your rocket's flight computer will read gyros or accelerometers to run your adaptive MPC and output fin commands. All inputs in under 100 millisecond loop. Embedded C lets you do it without an OS slowing you down. Embedded C doesn't use an OS. Embedded C uses a literal fucking hardware. So the most basic structure, obviously. So void main. So we don't use int main. We use void main. So void main, and then hardware. So turn on the hardware, set up the timer, set up the configure the sensor ports and whatever. The hardware in it. So that's how you code hardware in it. All right, hardware in it. So this is where. Oh, sorry, my bad. So all the this is where all the hardware initialization will be done. So hardware initialization are like sensors, motors, actuators, everything will be done under this. Oh no, it's not. Sorry, my bad. It's not It's not hash. It's right. So whatever process we are doing in order to embed that, all will be in the hardware in it. So whatever we are trying to embed, whatever we are trying to, um, you know, whatever we are trying to embed, whatever we are trying to control the sensors or control the timings or control the rocket or control the missile, anything that correlates to focusing on the hardware, everything will be inside this init function. So while one, so it's going to run forever. And the only reason we want it to run it forever, because every single second count. Our main aim is to get measurements quickly under 100 milliseconds. So we must make sure that it doesn't stop. Because if it stops, you never know where it's going to stop. You may miss crucial details. So the robot, or not the robot, the AI model, the hardware will read the sensor data, will make the decisions, will control the actuators here. So everything will be controlled. There will be no stop, right? So obviously, then you're then going to create a function. So let's say read sensor, and then make decisions, and then control the actuators. So it's going to read the sensor, whatever the like. We're going to create a function where it's going to read this. Obviously, we're going to create a function for that, but it's going to, I don't know, like whatever the code you did. So here, whatever program you did, so whatever you coded, whatever you inserted the code or whatever, so whatever you inserted the code, like however you did the program, so however you did the program, like you did the maths, you program the maths, you program the calculations and stuff, everything will be done under read sensors, right? So let's say, for example, if I were to say read sensors, so think of it like, um, if the rocket trajectory banks 3 degrees, then make sure that the whatever the equation for the coefficient for rotating moment in correlation to the side slip angle is, we're going to import that, and it's going to go negative. So let's say we did that, and what that's what the read sensors will do. So whatever procedure exists inside that function, so whatever procedure exists inside the function. Oh wait, there's something else I need to do. Yeah, yeah. Embedded C programming language streaming on kick.com. So I'm just going to, uh, where's the OBS? I'm just going to take a screenshot of this. Full screen, snip tool, screenshot, programming, embedded C programming language for missiles. Let's go. Ho, ho, ho. Anyways, so obviously you're gonna read the sensors, you're gonna run the guidance, you're gonna output the actuators, and then you also have to create wait for next cycle. So this wait, actually we can do 100 wait for 100 millisecond before the next loop iteration. What's the difference? What would happen? Actually, I have a question. What would happen if I what would for the wait part, for the wait function? What would happen? No, actually, let's do wait for next cycle. And the reason, so I'm going to write wait for next cycle. I know DeepSeek showed that. But the only reason I did this is because if I were to write wait 100 millisecond, you may not need 100 millisecond all the time, because you must make sure that it's always under 100 millisecond. So when you just read wait 100 millisecond, when you just read wait 100, then subconsciously you're saying that, okay, I'm gonna make sure I'm gonna make sure that after exactly 100 millisecond I'm gonna do the next cycle. But you never know what will happen after 100 millisecond, because you never know that it's going to output that key part. Although yes, then you're going to say that, okay, then in the next time step this happened, in the next time step that happened, even though it should have been in the previous time step, not in the next time step, right? So you never know. But if you have a function, then you have the maths and whatever. Like if so if it hits 100 millisecond, and then make sure you move on to the next cycle and then stuff like that. But you can also add your own special cases, right? But if you just add wait 100, then you just have 100 milliseconds. So what happened after 100 millisecond is going to go back again, right? But you never know that whatever key information that exists the next one, it should have been existed, or should have happened in the previous cycle, not the next cycle, right? So writing a function is better than just subconsciously writing wait 100. I mean, the sensor will automatically, or the chip or whatever the hardware is, it's going to automatically read, okay, wait 100 milliseconds. So after 100 milliseconds, go back again. But in some most cases, you don't want that, right? You want to make sure that it happens on the cycle itself. Good stuff. Okay, tiny concrete example. So we have an estimated thrust, so 10,000 newtons. It is estimated because for hypersonic missile, you don't use 10,000 newtons. 10,000 newtons for a hypersonic missile is pretty less. You'd rather go for like 40,000 or 50,000, because again, it's a hypersonic missile. And again, whatever values I'm saying are just an estimate. Whatever values I'm saying is just an estimate. But again, I could be right, because it's a hypersonic missile, right? Like, you don't want to have less power, and then at the end of the day, it's like, fuck, I have less power. I can't do anything about it. Shit, right? So the float estimated thrust is 10,000, so 10,000 newtons. The update thrust based on the sensors. So we actually have to create a function. So update, wait, read accelerometer. We don't have that function yet. We have to create the function, correct? Because I see that there's a bracket. And the float expected acceleration, estimated thrust divided by the current mass, and the float error measured acceleration minus the expected acceleration. Estimated thrust will be estimated thrust plus 0.1. So 0.1 is the infinitesimal time step between the um, previous value you got, the previous thrust value you got, and the current thrust value you have, right? So let's say, for example, and the only reason we have 0.1, although it's a good practice to not have 0.1, rather have 0.01, because if you have 0.1, you don't know what happened in 0.09, 0.08, 0.07, and whatever, right? And what happens is that in between, something can happen. And if you want to have more information, if you want to have more details, 0.01 is better than 0.1. And give me 2 seconds. All right. Sorry about that. And then void main void or whatever the function. Now I just want to I understood what's going on. Actually, let me do one thing. Let me just uh, hoo. Me. Let's actually code this. You guys can see, right? You guys can see, right? Can you guys see the? Actually, I think it should be here, right? My face should be here. This should be there, and my face will be here. Because the main the main thing is not the the AI part. AI as in the embedded C, the explanation, but what I'm coding, right? You can write include, and you don't write IO stream. IO stream is for C++. IO stream is for C++. Yeah, I need to cut my hair. I genuinely need to cut my hair. Because look at that hair. Like my hair length goes all the way until here. My plan is like I have like much larger hair, like all the way until my shoulder, like somewhere here. Like that's my ultimate plan. Like that is my ultimate plan. Um, how do I have it picture play? Hmm. How do you how to let me just check. Oh come on. Surely like oh I don't even get any views. That's sad. Well it sucks to be me then. How to have picture in picture on OBS. Leave it. Leave it. Let's just keep coding. So we have include IO stream, include IO stream, and then float. Nope. Estimated thrust. I'm going to use my own value. So, hmm, is it a good idea? Float mass and float. I mean, yeah, we can do that, but we are not done yet. And why is that? I'm sorry, wasn't it working before? Oh, I used. Okay, my bad. IO stream is for C++. And then let us write a void update trust. What's a star? Generate Copilot summary. So just wait. Oh no, 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 no. Okay, leave it, leave it, leave it, leave it, leave it. The mass acceleration, and then we can add an error. Wait, wait. Ooh. And then we can also add another function, void thrust error. Thrust, mass, and acceleration. Thrust will be the estimated thrust for mass and acceleration. Mass would be because simultaneously the mass will decrease, so by like by 5 kilograms, and acceleration will be minus, you know, whatever the acceleration was minus. Actually, what does this mean? Simulate the mass decrease, simulate the acceleration decrease. One thing I want to do. I don't know if this is correct. You know what? Don't auto complete it for me. Thrust error, float of thrust. What does this star mean? I'm confused. What does this star mean? There's a star over there. What does that star mean? Um, that star. What does that mean? So mass also changes, right? It's not the thrust. So look at this problem. Only changes the local copy. Why C passes the argument by value. Inside the function thrust is a copy. And now if I use a pointer, now inside the function, the thrust means go to the address stored in the thrust and change what's there. So this is called dereferencing the pointer. Okay, I still don't understand. Okay, I'm still confused. I am still pretty confused. Confused what's going on. Can you explain it again if you don't mind, please? Imagine a flight's computer memory is a long street of mailboxes. So an address has like 101, 102, 103. So address 101 is 10,000, 500, and address 103 is 20. Now you live at one mailbox. When someone asks, what's your thrust? You say 10,000. Pointer variable is like a sticky note that says, go look into 101. It doesn't hold a number like 10,000. It holds an address like 101. The reason we need pointers is because let's say you have a helper function called update thrust. You tell, please update my thrust to a new value. Without the pointers, you'll say that without the pointers. So you write a note to your helper. Here's a copy of my thrust value. Please change this copy. The helper takes your copy, changes it to 9,500, but throws the paper away. So it changes to 9,500, but the original mailbox will be 10,000. This is what happens when it gives the function a copy. Meanwhile, your original mailbox still stays 10,000, so nothing changes. Now, here's the address of my trust mailbox. Please go there and change whatever is inside. The helper goes to one mailbox 101, opens it, changes. Okay. So, not adding star is like, yeah, you did change from 10,000 to 9,500, but who cares? It is not um saved. But if you add a star, it's like saved. Would it be the same case for mass and acceleration? So I'm curious. I'm curious. Then wouldn't it be wouldn't it be the same case for the mass and acceleration? Mm. Anyways, uh, so why won't you have? Actually, I want to run this code. I want to actually run this code. Let's run this code. So before call, we have thrust is 10,000, mass is 500, acceleration is 20. Inside the function, we have 9,500, 510, and 22. Oh yeah, inside the function we call that the 9,500, uh, 510, and 22. Now we're going to call the thrust, mass, and acceleration. We have the thrust, we have the mass, we have the acceleration. And we have now 9,500, 520. That didn't change. The value didn't change because actually, you know what? I want to code this. I want to code this thing. So I'm going to write include IO, not IO stream, stdio.h, and then void, what was it? Void update thrust float, thrust float, mass float, acceleration. So I'm just going to write, no, wait. Okay, thrust is mass times acceleration. Let's say mass is 500 and acceleration will be 20. We're gonna have, yeah, let's say acceleration is 20, right? Cool. And so now we're going to print the printf. Inside my function, I have whatever, right? Cool. Cool. That's fine. So I'm gonna have, actually, I have mass, nope, mass, so I have thrust, mass, and acceleration. I have thrust, mass, acceleration. Then I'm going to put a comma here. What did they do? Thrust percentage F, mass percentage F, acceleration percentage F, and then move to the new line. So thrust percentage F, mass percentage F, acceleration percentage F. Then we put a new line. Then we're going to write thrust, mass, acceleration. Right? Did I make a mistake? Thrust, mass. Oh shit. Thrust, mass, acceleration. Was that good? Yes. We already have the values, right? We already have no update thrust. So this is mass should be whatever the mass was. I'm going to put a plus here, 10 percentage OF, and this will be not going to write, I don't know, 3.75 or 3 OF. And I'm going to write int main float of mass will be not 100, it will be 10,000. 0 float acceleration will be 9.81. Pretty simple. And float thrust, we have it 0 at the moment. I'm going to call the update thrust function. So in main, thrust is this, these are blah blah blah. Actually, no, we're going to write before. Printf before calling the function. Before calling the function, I'm going to put this. Before calling the function, thrust is percentage F, mass is percentage F, acceleration is percentage F. Right? And then now I'm going to call the update thrust that there. You write update thrust, and now I'm going to printf after calling the function to thrust mass acceleration. If I run this, what I have is before I call the function, I have thrust as 0, mass as 10,000, and acceleration, wait, oh god, acceleration is 9.81. Now, when I inside my function, which is the void is the function, and inside the function, after all the calculations and stuff, I have 98,100 because it added. I have the mass by 10 because thrust is equal to mass times acceleration, so I multiplied that. I got the mass, I got the acceleration. This should be the case. But my mass and acceleration did not change because it's like saying that yes, you did need to change the value, but the real address did not read the changed value. The real address read the original value. So technically, it doesn't change. Now, if I did put this to star mass and star acceleration, and then I'm going to change all those. Now, if I run it, okay, I think compilation will fail now. We're going to have and mass and acceleration because now the address is changing. Because now compilation successful. Now if I do it, so before I have 0, 10,000 and 9.81. After that I got my thrust, I got my mass, I got my acceleration. And now I have my thrust updated, I have my mass updated, I have my acceleration updated. And I must make sure that if I'm updating it, then I'm going to have the and symbol behind each of the variables. Just yeah. All right. Let's keep going. Keep keep going. And let's do let's keep going. Let's keep going. So every variable must have a type. This type tells the computer how much memory to reserve, what type of data it can hold, what operations you can do with it, like add, multiply, shift bits, whatever. Basic variable types in embedded C. So character is 1 byte. So a whatever, right? A minus 50 whatever byte character. Unsigned character is 1 byte also. So a character is usually a signed character. So you're gonna have from minus 128 to 127 because obviously it's signed. So negative also exists, positive also exists. Unsigned character like 100. Um, integer. I mean, 200 technically you have to write character, right? But usually, like if you write character, then you know, typically it's always a signed integer. Or sorry, yeah, signed integer. Int is 2 or 4 bytes, so whole numbers, pretty much. Unsigned integer is also 4 bytes. Oh, it's actually 4 bytes. Short is 2 bytes, small or whole number. Long, float, double. So why this matters? Because in a flat computer, memory is limited. So maybe 64 kilobytes or 256 kilobytes in total. You can't waste it. You need a double to store a fin angle that only needs 0.1 degree precision. Float is fine, or even shorter if you're doing it as a fixed point, but a fixed point is never good. The best option is a double. The best option is a double because you have more storage, so you can input more values in it. And the special types of embedded systems. So, okay, what are those? Unit 8, so that's 1 byte. So, like sensor ID, state machine state, or whatever. Int 8, that's unsigned integer. This is a signed integer. 1 byte, so minus 128 to 127, so like small errors or deltas. So unsigned integer is used usually when it comes to measuring the sensor data or whatever, but the signed integer is usually used when you want to measure the errors or the difference between maybe acceleration or difference between maybe time or difference between maybe the trajectory or whatever. And then unsigned integer 16, so obviously there's higher values. So if you want to read the actuator values or the ADC readings or whatever, the integer 16, so the signed integer typically. So you're going to measure the angular rate, meaning you're going to read the pitch rate, or you're going to read the nose down, nose up, or so you're going to read the pitch rate, you're going to read the um, the side slip angular rate or the angular velocity difference or whatever. And then unsigned integer 32, so obviously 0 to 4.2 billion. So you're going to read the time that time must be measured in milliseconds. And like I said, every single millisecond counts because I'm going to have 0.01, 0.02, 0.03, 0.04. But each of those, because I have 0.1, 0.01 millisecond, doesn't mean my storage will be 0.01. My storage will still be 1, right? The 0.01 is a value, but where I store the 0.01 exists in some box number 1. Box number 2 has 0.02. Box number 3 is 0.03. Box number 4 is 0.04. Box number 5 is 0.05, and so on and so forth. And so each of those timings, because if you want more accuracy, then obviously you'd have to go for higher bit values, right? U is unsigned, yes. Uh, what's the difference between STDIO and STDINT? Go slowly. Wait. Go slow. Calm down. Calm down. Go slowly. Let me try to understand what's going on. What is the difference between STDIO and STDINT? Going to write, was I not good enough? Was I not good enough? Man, once I get this fucking premium, oh man, I cannot wait, man. I cannot wait to get this dumbass premium. And after that, I'm gonna beg Valentine, please. I'm sorry, I'm sorry, I'm sorry, I'm sorry, I'm sorry, I'm sorry. I'm gonna beg Valentina, like I'm gonna beg her because I mean I did everything I could. Let me just boom. Oh crap! Eh, good. Anyways, so stdio only if you need to print or read files. Stdint is always in embedded Rocket. So I have one more question. Do we always, so let's say for example we were, so let's look, let's say we are programming, right? Let's say we are programming, and while we do the program or whatever, while we do the program or whatever, can we have both stdio.h and stdint.h? Can we have both of them? Can we have both of them? Oh, that is common. All right, cool. stdint, and then and then include, and I'm gonna add the libraries too. I mean, I'm gonna do that then. All right, let us move on. How many chapters do we have left though? Oh, okay. Unit 8, phase 2. So okay, okay. You have to write it like that. I am so confused. If I write int main, I don't think it's going to work again, right? Can it? Can it work again? The unit 8 T phase 2. Oh my god. Why am I? Is it because I wrote int main two times? I think I wrote int main two times, right? Okay, I have. So if I will just read. If I write int main, and I'm gonna write unit 8 t phase, unit 8 t phase is equal to 2, unit 32 t flight time is 10,000, and we're gonna print this, and we're gonna print this, and we will return 0. Now I have one question. I know if I run it, I'm gonna. Oh, it's unit unsigned integer 8 and unsigned integer 32. Why did the compilation fail? Did I do anything wrong? I don't recall doing anything wrong, right? I don't know. It keeps saying Like from I don't know, it keeps saying compilation failed. Why? Okay, I don't understand. Is it because I wrote int main two times? So I'm getting this error here. I'm getting this error here. Is it because I wrote the int main two times? Oh, because I wrote int main two times. Then what I'm going to do, so how do I fix it? Ah, yeah, it does. So I can have all the codes. Actually, let me, and if I have, okay, I have one question. If you write, how did he write the, okay, you int 8 underscore t. So you int 8. Oh my God, what is this? Wait, let's not jump. Let's not jump. You int 8 t phase. Let's say it's and you int 32, let's say the flight time is 10,000. Then I'm going to you int or 32t, then print f phase u flight time u in seconds, then print f, and then we return 0. Now let's run it. So phase 2, what is phase and what is phase? Is it yeah, what is phase? What is phase and yeah, what is phase? I know what flight time is, obviously. What is phase? Why does time have? I know it's percentage u, and then seconds. What is ZU? What is LU? What is ZU and what is LU? Z is integer. That's all I know. What is phase? What is ZU and what is LU? Okay, yeah, I know that, obviously. No, percent long unsigned, usually 32 or 64. So there is, and what is percentage ZU? Then what is percentage ZU? Size of. Okay, that's so cool. So percentage U. So what do I have to know apart from percentage U, percentage LU, percentage ZU? What else do I have to know? Okay, is it possible like do you have to know percentage D, percentage U, percentage D is signed integer. So percentage D is signed integer. Okay, is it possible to like combine all those? So percentage D is signed integer, percentage U is unsigned integer. So that's only positive. And then percentage F is a floating point. Percentage C is the character. Percentage S is a string, the array of characters. Percentage X is hexadecimal. So print percentage X 255. And then percentage P is memory address. Percentage LU is long unsigned, like unsigned long, or like the unsigned integer for 32. And then percentage ZU is the size of, the size of unit 8 is 1 byte, size of unit 32 is 4 byte, because that's 2 to the power 2, 4, or 8, 16. No, wait. Yeah, 4 bytes. 4 bytes and 1 byte. Less common but useful. Percentage LLD is long, long signed, very big numbers. Percentage LLU is long, long unsigned. Percentage E, scientific notations, and percentage point 2F is a float with 2 decimal points. Is it possible to combine all those and into one table? Okay, we have a full code here. I'm just going to uh, copy this. Yeah, I'm just going to copy this. What what like, wow. Wow, Lockheed Martin. During the battle. Does the Hercules come directly? Again, I am stupid. There's the blue moon today? Shit. All right, let's continue. I'm just going to write the code for this. So u int 32t. Okay, what is pointer? What's this? What does this mean? You know what? This is chapter one. I'm just going to go a little slow. So u int 32t time in millisecond will be 1, 2, 3, 4, 5. U int, no, not u int, there'll be a signed integer. So int 16t pitch rate minus 16, and then float thrust n 98765431. Yeah, it's again random values, random values. And then float altitude m 1523.8. And character stage power flight. We're gonna print all those. The print, and then we return 0. The time is 1, 2, 3, 4, 5. Pitch rate is minus 16. Oh, 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 oh. How do you know? How do you know? Oh, wow. So percentage U is, what was percentage U again? Is it possible to like the table and what like? Let me first of all look at the book. Where's the book? Oh, there's a lot. Mm, it's okay. Okay. Where are we so far? Holy shit. Operators and expressions. So an expression is a statement in which an operator links identifiers such as when evaluated, the result may be true or false or numerical value. Operators are symbols that indicate to the compiler what type of operation is to be performed during the what? Okay, which type of operation is to be performed using its surrounding identifier. There are rules that apply to the procedure order in which the operations are performed. I want to do this. 1.6. Can you explain what's going on at 1.6? Is it possible to, okay, where is it? Actually, let me move this here. That, put that. We are recording, right? Yeah, we are recording. Two watching. All right. Two people watching. Cool. Yes, let's go. All right. So operators and expressions. What I'm going to do is actually, I know that there's this true, false, and whatever. I know. Again, I know. But I'm not going to learn in correlation to what exactly the book has, because again, this is embedded C. I did C. I'm good at C, but I've never done embedded C, because embedded C is mostly in correlation to the engineering point of view. I've never done engineering because I am not an engineering student, sadly. But I'm learning. I'm learning. I mean, name me one person who is doing what I'm doing. Nobody. I mean, at the end of the day, you have to learn, right? You have to start something to be somebody, right? So far, let's just what is going on. I want to understand less English, more maths. Just explain the code. What is going? Man, I'm so happy. Like let's fucking go. Two people are watching. Anyways, holy shit. Yes, yes. Two people watching. Let's go. I have 4 followers. I have 4 followers. Four. Anyways, slowly, calm. Slow, calm explanation. Is it possible to explain what is going on? Like slow down, slowly, calm, slow, calm. And I know the book has true, false, or whatever. I understand Boolean. I understand Boolean. No, who doesn't? Book has false, whatever. But is it possible to explain in correlation to the abstract? Just slowly, calm down. The expression is anything the computer can calculate to get a single answer. So 5 plus 3 is 8, because that's addition. Thrust greater than 1000, so calculates to either true or false. And angle times 2, so calculate restores some number. So if, like, I've never done embedded C, so please don't laugh at me. I've never done embedded C. I did C, but I've never done embedded C. Like that star or whatever, I didn't knew what star was because I've never used that in C. So a paper says the system continuously refines the key parameter. So the refinement requires the calculation, meaning expressions. New thrust will be all thrust plus correction factor multiplied by the error. So it's using equals, it's using the addition, it's using the multiplication. So at the assignment operator, the equal does not mean equals like in math. It means put the value in the right into the variable on, put the values on the right into the variable on the left. So if you add them, if you have like mass value, if you have let's say if you have mass value, if you have, I don't know, correction factor value, and if you have error value, you do all those operations, you do all those calculations, and whatever the value you get, you move to the left. So it's stored as a new value, new variable called new thrust. Let's do one. Write a full code. Wait. Write a full code, full one whole code in correlation to the abstract that covers chapters 1.6.1, 1.6.2, 1.6.3, and 1.6.4. Wait, just write the one whole code. Just write one whole code. Don't explain yet. Don't explain yet. I just want to see. I just want to see. Don't explain yet. Then what I'm going to do is, no, sorry. And then I'm going to move this half. So the STD and int, this is mostly used like if you want to focus on the numbers and whatever, because in most cases we're going to use this, because if you were to focus on embedded, maths always maths. Let's go, hard work. STDIO is like calling out, like printf, right? It's like calling out the function normal. Like if you if this is why, like, look, like std int, I've never used it because you use it in embedded C. I've never used std int. It's my first time learning. You can laugh all you want, but I've never done embedded C before. It's my first time doing embedded C. Okay, float thrust estimate, and then float mass, float measured acceleration, predicted acceleration. Then you can calculate the gain as in the infinitesimal gain, and then error. I want to code it out. I want to code this. I'm just going to write include stdio.h, include stdint dot h, and then I'm also going to add the library, include std library dot h, int main void. You have the float, you're inserting the values like thrust estimate, mass, the measured acceleration, predicted acceleration, gain, and error. So float thrust estimate, I'm just going to write thrust value 10,000.0 f, then float mass, let's say 500.0 f, meaning that this is in float value. Reason being, I know that they wrote 0.0 f, but the only reason it's best to The only reason it's best to write there is because you have double. And when you, I mean, yes, we did float, but actually, why do you, no, why do you write F? Wait, wait. On, on float values, let's say you didn't write 10,000.0 f. Let's say you only wrote 10,000 or 10,000.0. Would that work? Or would that not work? That not work. Wait, I still have views, right? Jeez. Bottom score. All three would work. Okay. So we want to be on the safe side, right? So all three would work, but again, it's an embedded system, so there's seals like then float measured acceleration. No, I'm not going to write 19.6. I'm going to follow what he did, 18.0 f. So I'm just going to write here the only reason we add point 0 f, we add point 0 f is because we want float seal value. Like we want float 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 seal value because double has less bytes than float, and it's an embedded system, so anything can go wrong. And if you don't add point 0 f, because I mean, pretty sure like everyone is pretty aware, like even a small bug can cause like big issues, big issues. So I don't want to cause any issue because I know for a fact that although I'm thinking, yeah, I don't have to write point 0 f, that's completely fine. You never know. You never know. This habit will keep on coming up. Oh, I can't write. Oh, I don't have to write. I don't have to write. You're fucked then. And then we got the measured acceleration. No, not yet. Float predicted acceleration. Let's say 20.0 f. And then we got the float error. Actually, we can. That's fine. Do we go for star or do we? I'm not. I don't want to do any calculations yet. I'm sorry, not calculations. The print values yet. The calculations I have to do. Error. Oh, I wrote the equation, right? I wrote the equation already. And thrust estimate. How do you calculate thrust estimate? Oh, I forgot to mention the gain. So float infinitesimal gain 0.01 f. We're gonna go like as accurate as possible. Nope. Wait. Error will be measured acceleration minus the predicted measured minus predicted. Oh yeah, measured minus predicted. So this is not predicted. This is actually what you call desired. Yes. The desired acceleration minus. I have already done the calculations. How do you calculate thrust estimate? Hmm. What do you call? I know gain temp. You know what? I'm just going to say float. Derivative will be gain multiplied error, and float thrust estimate or thrust correction will be thrust value plus derivative. We have the velocity, don't we? We don't. Float velocity initially it is 0 and float time step is 0.01. It's not gain, it's infinitesimal gain. Infinitesimal gain. And then delta V is a time step. I mean, infinitesimal time step, whatever. And then for, actually, let's read this. For I equals 0 to I less than 100 and I plus plus. This means that you're going to start from I equal 0 millisecond. And because my abstract specifically states less than 100 milliseconds. So all the calculations must be done in less than 100 milliseconds. So you're going to get all the calculate. Actually, I have to also set Um, I being 0.01, because this is going in 1, 2, 3, 4, right? And I don't want that. Oh, we have it. We have it. Good. We have it. We have it. That's index. My bad. My bad. So I equals 0 to I less than 100. So 0 to all the way to 99. And then you're going to keep on adding by one index. So index 0, index 1, 2, 3, 4, whatever, so on and so forth. And the velocity, you're going to add that. So velocity will be velocity plus the thrust correction divided by the mass times time step. That's how you calculate velocity. How do you calculate Wait, that's how you calculate velocity. What is thrust correction divided by the mass times time step? MDT. Del T divided by MDT. That's how you calculate it? I never knew that. I'm just curious. No, that's fine. That's fine. Just give me, is that how you calculate? I just want to check specifically on this one. Is that how you calculate the velocity? The updated velocity, is that how you calculate the updated velocity? Shouldn't that be updated velocity? No, I know. Force by mass. Yeah, I know. Old velocity plus force by mass times time step. What? Force by mass? I don't see any force by mass here. Wait, new velocity is equal to old velocity plus acceleration times time step. So wouldn't that be the equation? Then why don't we, okay, then why isn't this the answer? So velocity will be equivalent to velocity plus thrust correct. Oh, oh. Thrust correction is the force. Thrust correction is measured in meters. I am so stupid. I am so stupid. Thrust correction is measured in newtons. That's why I was like, why the fuck do you have mass times time? Ah, it's thrust correction by mass. This motherfucker is actually acceleration. So I'm just going to note that thrust thrust correction is measured in newtons. Like, what the fuck is going on? If I run it, let's run it. Oh God. Look at that 0, 0.01, 0.02, 0.03. Um, that's 1 second, right? So see, like you can see that the velocity increases. Just wait, just wait. If I went 0.1, then you see like, right? You have missed like so many values in between. So which means that you're going to get error. Fact, you're going to get error, but at the same time you're going to get error that happened in between 0.1 second, but you never know that in between 0 and 0.1 whatever error happened on that phase there, that little phase over there, maybe let's say for example the rocket or the missile did not fully um, burst out a lot of thrust, but you never know why. You may think that, oh, okay, it's between it happened on 0 to 0.1 second. Let's say it's 0.2, this happened. But you're not going to get like, okay, why did this happen at this time step? Or why did this happen at that time step? You never know that between the 0 and 0.1, the values in between, that matters a lot. And I am going to write 0.01. I know it's going to use up a lot of memory. I'm aware of it. I'm well aware of it. I'm well aware of it that is going to take up a lot of space. But I am going to make sure that on the next few chapters, I'm going to make sure that I try to build a model that's going to have as many time step values as possible. And on top of that, is very efficient. So you don't have to read all of it. It's going to only take out the key values, because here it's like it's taking all of it. And I can't, what I mean by that is like, I want to keep 0.01, but at the same time, I want to be also efficient. Like, where is the error? So it's not going to grab all the information. It's only going to grab, let's say, a section of it. Uh, mm, and then what about how do you do the if else part? How do you do the if else part? How do you do the if else part? Where's the if else part? Holy shit. So if altitude is greater than the max altitude, the flight phase will be 2. If thrust estimate is greater than or equal to the minimal thrust, like the minimum thrust, and the thrust estimate is greater than or equal to less than or equal to the mass thrust, then it is safe. Why do you have a 2 in there? Okay, I don't understand this part here. I don't understand this section here. Can you explain this section here? I don't understand that. Are people still watching? I don't think they're watching, right? Oh, oh, look, people are still watching. People are still watching. Oh my god. I know, I know I look different now because my light and there's no sun here. So relational operation, the compare operator. So obviously that means greater than, that means less than, that means greater than or equal, less than or equal to, and not equal to. Yes, we know that. So if, what is flight phase? I'm confused. What is flight phase? The flight phase is simply what stage of the mission the rocket currently is. So think of a rocket's journey as like a road trip. Still in the garage, pre-launch, driving on local road, power ascent. Oh, pre-launch, power ascent. So do they mean to do like okay? So it's like a code book, right? Ah, okay. Phase number 0. I'll be back. So we have 0. So does those phase number? Okay, we still have do we still have two views? I really want to see. Please, please. I'm so sorry. I'm so sorry. Yes, we still have two views. I want to check one thing. I want to the phase numbers, are they also like are the code values same for missiles or is it different? Okay, so the same concept. All right. So 0 is what? Pre-launch. 1 is boost phase. 2 is mid-course, so motor burned out, coasting towards the target area. 3 is terminal phase, active seeker on, making final maneuvers. Impact target hit. 99 is abort. Wow. 0, 1, 2, 3, 4, 99. Learn them. Learn them. Learn them. Learn them. Go, 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 go. Learn them. When people on the radio will be like 4, 4, 4, 4, 4, then it will go, oh yeah, 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 4, 4, 4. Right? You can have this radio like 4, 4, 4 or whatever. Like I don't know. I don't understand. Like I'm so sorry, but I don't understand. Like how do they say? Like do they say 4, 3? I don't know. What do they do? But yeah, phase numbers. Phase number. Learn them. Learn them. Learn them. Learn them. The numbers are just chosen by the oh, then oh, fuck's sake. God. Wait, you can pick any number? Nah, I thought that was, I thought that was, I thought that was the. Okay, it's not work. All right. So let's go back again. Where's the code? So here they said, wait, where's the code? If altitude is greater than max altitude, then flight phase is 2. So it is currently at coast phase. Could code that. Nope. Do I write if here? Like inside the for loop? So if I write if altitude is greater, do I have altitude? I don't think I've defined altitude, right? Did I define altitude? Actually, I have one more question. One more, wait, one more question. Dude, I'm sorry if I have so many questions, but in real life, you're not going to have. Actually, I'm going to add float altitude. Initially, it'll be zero point 0.0 F. No, it's not going to be zero point 0.0 F. Let's say 5,000. And float max altitude will be 10,000. And then now I'm going to say if altitude is greater than, yeah, I'm just going to. Actually, great question. Let's start from zero, right? Why not we start from zero? Why not we start from zero? And then what I want, if altitude is greater than or equal to max altitude, then I'm going to print altitude reach 1000 meters. Does it stop the simulation? I don't think it's going to stop the simulations. I don't want it to change the simulation because if it changes the simulation, then it's bad. What do I do instead? If altitude is greater than or equal to the max altitude, I just need to change the phase number, right? Um, do I say change phase number? The altitude reached higher than higher than. How do I write? How do I put a bracket? I got Mary Brown's. Get it? Oh, come on. What am I going to eat now, though? Anyways, if altitude is greater than max altitude, then flight phase will be 2. Altitude reached higher than. How do I? Reached. Just wait. Um, I have a question. In C, in embedded C, in embedded C, how do you write the variable name? So what I want to do is like higher, let's see, higher than max altitude, changing to we reached phase number. for now, I'm not going to set any phase number for now. Higher than percentage to FM. What's M? I didn't find anything called M. Percentage to FM. Oh, meters. There's no phase. Mm. I'm so sorry. I'm so hungry. I'm so sorry. And if the thrust estimate is greater than or equal to the minimum thrust, and the thrust estimate is less than or equal to the maximum thrust, yeah, because if this is the case that where the minimum thrust is greater than the thrust estimate, and the because in that case it's going to push because not because it's going to be damaged or aborted in the middle during the launch, but let's say for example you're here and you don't have that much thrust, it's going to fall down, right? And if you have more than what is required, then obviously what happened to Jeff Bezos today, right? If I'm just going to write again, if thrust estimate minimum thrust and thrust estimate max thrust. Okay, why did you finish it? Printf? We are no, no. We can't just write this. We have to set phase numbers. So this should be, what I'll do is u int 8, u int 8, t, what would this be? Phase, flight phase. It'll be 0 at the moment because obviously it is, we're presuming that it's at the ground. And we're also going to u int t is safe 0. So at the moment it is 0. I mean, it's not necessary to go for the 16 byte. Like for 16, you don't have to go for 16. Or you don't have to go for 32 because this is a Boolean value 0 or 1. So the shortest here you can go for is 8. So I'm just going to write, don't put a break here. And I'm going to write flight phase 2. We don't have the, it's not thrust estimate, it's thrust correction. Thrust correction, minimum thrust and thrust correction, and then is safe 1. So meaning it is safe. And then if altitude greater than maximum altitude or thrust estimate less than minimum thrust, then you shut down. We can do that. That's you make sure that you don't want that to happen. If altitude, max altitude, and thrust estimate, minimum thrust, and print. And we're also going to print, not print, sorry. Um, nope, is safe is 0. And the flight phase, 99 in this case, meaning abort. Or whatever the value set. What is this? Loop counter. So you in 32 loop counter zeros, obviously you're going to have very high values. u int u int 32t0, because you can have so many time, like, because if you have like 0, then 0.01, 0.02, 0.03, 0.01 will not be stored at, you know, 0.01, 0.02, 0.03. Each of them have their own index, and once an index occupy, it, you know, loses one store, loses another, loses. So the memory is increasing, 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 because many of those values are being occupied. But if you have 32, you have a lot of open storage spaces, right? So the only reason we don't write u int 32 is because in this case it's like 0 and 1, and for flight phase also there's only 5 values. You have on 0, 1, 2, 3, 4, and 99. So on ground, in cruise, you know, doing the final trajectories, going to hit them, going to hit the target and abort, right? So counting all those, you only have 5. But if you have 32, 5 of them will be occupied. But you must also understand, if all of them are open, because the main storage is going to occupy all of them, but they kind of goes out like, wait, I can do that. I don't mind doing that. Let's see, like UN 32. I don't mind doing that. It doesn't, I mean, pretty much, yes, because why would you want so many spaces for such, I don't know, 0 and 1? And did I make a mistake? It's not minimum thrust, right? There is no minimum thrust. I think I need to also put float minimum thrust and float maximum thrust. Let's do that. Why? There is an error. Okay, you know what? Forget it. Forget all those. Forget all those. It worked. We did it. It worked. I'm not saying it didn't work. It worked. But why do you want to put way too many storage openings, right? Like it's like saying that you have a huge mansion, like huge, but only you're the one who's staying. Like, why do you need a huge mansion if you're the only one who's staying, right? And float steering, loop counter time, fuel mass, total impulse mass, float steering's angle error, max angle, and steering command, character, stage character. What the fuck is this? I'm sorry if it's too boring, but I'm trying to understand like what's going on here, and I'm pretty hungry. Let's do that. I'm sorry if I'm so hungry. I am so sorry. I am so sorry. U int 32t, the loop counter. Did we write loop counter? No. Loop counter is 0. And then if flight phase is 2 and is safe, then in flight phase 2 and the system is safe. Else, no, we don't have to write else. But what does it do? I'm so confused. Like, can we run this? So if I write return 0, for I, right? It should be for I. For I 0, I 100. If, now I'm going to write if, no, wait. If flight phase is 2 and is safe, then yeah. But what happens is that it only counts. Why does it only count the first one? I'm curious. Okay, for this, so I wrote this code here. I can zoom out, right? No, I can't. So I wrote this code here. I wrote this code, and it only shows the 0.00 seconds, but not like it doesn't measure, it doesn't, calculate every single time step, and then once it hits, once it hits the set, what it sets, once it hits the set unsafe value, it stops. Like, why doesn't it do that? Oh, I plus plus, yeah. So the first part of a for loop must be initialization. Okay, I'm confused. Oh, the uint loop counter is okay. I should be declared uint 32 ti. Now will it work? So for I is zero, or I'm not comparing anything. My bad. I less than 100 and I plus plus. If flight phase is 2 and is safe, then flight is safe. And there is no else. And if some condition met, then flight phase is 99. Okay, we also have to do that. Yes. Uh, wait, we don't have a function called some condition met, right? Then what I have to do is if no, wait. But what if, because I can't write. Oh, I'm so tired, man. You know what? I'll just stop. No, man. Thank you guys. I'm tired.